Welcome to episode 64, Products that Help You Meet Sustainability Goals. Achieving environmental progress in the cloud requires more than good intentions. It requires practical tools that convert strategy into measurable action. Google Cloud provides a growing suite of products and features designed to help organizations understand, manage, and reduce their environmental footprint. These tools make sustainability operational, embedding environmental awareness into everyday decisions about where and how workloads run. From energy-aware infrastructure to automated policy enforcement, Google Cloud enables companies to align performance, cost, and environmental responsibility. The focus is not just on measurement, but on action, helping teams make informed choices that reduce emissions while maintaining speed, scale, and reliability. The carbon footprint dashboard in the Google Cloud Console serves as the central reporting point for sustainability metrics. It shows customers how much carbon is associated with their workloads, broken down by project, service, and region. The data reflects the mix of energy sources powering each region, allowing users to understand both total emissions and where improvements can be made. For example, an organization might discover that its analytics workloads in a carbon-heavy region produce more emissions than identical ones elsewhere. This insight transforms sustainability from an abstract concept into a visible, quantifiable metric. By integrating environmental data alongside billing information, the dashboard makes sustainability performance as measurable as financial performance. Google Cloud's recommendations engine extends beyond cost optimization to include guidance on reducing energy intensity. These recommendations highlight opportunities such as deleting idle resources, resizing instances, or moving data to lower carbon regions. Some suggestions overlap with financial optimization, showing that energy efficiency and cost efficiency often align naturally. For example, shutting down unused virtual machines saves money and reduces emissions simultaneously. Machine learning models power these insights, scanning patterns of resource use and comparing them with sustainability best practices. Acting on these recommendations ensures that sustainability goals translate directly into practical, automated improvements across infrastructure and operations. Data location choices play a pivotal role in reducing emissions because energy mixes vary widely between regions. Google Cloud publishes carbon-free energy percentages for each region, showing customers where renewable sources dominate. Selecting regions with higher renewable energy availability lowers a workload's carbon intensity without changing application logic. For instance, a company running batch processing jobs can migrate them to a region powered primarily by wind or solar energy. Paired with the carbon footprint dashboard, these insights let customers plan deployments strategically, optimizing not only for latency and cost, but also for environmental impact. Geography becomes a meaningful variable in sustainable architecture design. Serverless computing options such as Cloud Run, App Engine, and Cloud Functions help reduce idle capacity and energy waste. Traditional servers or virtual machines consume energy continuously, even when underutilized. Serverless platforms, however, allocate resources dynamically and scale to zero when not in use. This means energy consumption directly matches actual demand, eliminating waste from always-on infrastructure. For example, an application that processes requests sporadically consumes energy only during execution, not while waiting idly for traffic. By removing the overhead of manual provisioning, serverless computing delivers both operational simplicity and inherent efficiency. Running workloads only when needed is sustainability in action. Choosing appropriate storage classes helps minimize unnecessary data retention and the energy associated with it. Google Cloud Storage offers multiple classes, from standard to nearline, coldline, and archive, each tuned for different access frequencies. Moving infrequently accessed data to lower energy tiers reduces storage cost and carbon impact. Lifecycle management rules automate this process, ensuring that data transitions to more efficient storage after a defined period. For instance, daily logs could move to coldline after 30 days and then to archive after a year. This automation enforces sustainable data management at scale, converting policy into measurable reduction in energy use without manual intervention. Intelligent scheduling and auto-scaling strategies ensure that compute resources align with actual workload patterns. Auto-scaling dynamically adjusts capacity based on demand, while intelligent scheduling allows tasks to run when renewable energy availability is highest. For example, non-urgent analytics jobs might be scheduled during daytime hours in solar-powered regions. These techniques reduce both idle consumption and reliance on fossil energy sources. They also complement financial efficiency by preventing over-provisioning. Google Cloud tools, including Cloud Scheduler and Recommender APIs, integrate with monitoring systems to trigger smart scaling decisions automatically. By matching computing demand with cleaner supply, organizations minimize emissions without sacrificing performance. Network design can significantly influence sustainability by affecting energy use and data transfer efficiency. Reducing unnecessary hops and egress minimizes both latency and the power required for data transport. Designing architectures that keep computation and storage close to users lowers the physical distance data travels, cutting energy consumption across the network. For instance, regionalizing services or caching frequently accessed content with Cloud CDN reduces cross-region transfers. Network optimization is often viewed as a performance exercise, but it is equally a sustainability practice, streamlining data flow to consume less energy while delivering better user experiences. Analytics tools in Google Cloud allow teams to track efficiency trends over time and measure the results of sustainability efforts. Using BigQuery and Looker Studio, organizations can combine operational and environmental metrics to visualize performance improvements. Dashboards might show monthly emission reductions correlated with resource optimization actions or workload relocations. Tracking progress in this way turns sustainability into a continuous improvement cycle rather than a one-time initiative. For example, a company could measure how shifting batch processing from one region to another reduced emissions over successive quarters. Data-driven analysis transforms sustainability from intention into evidence, validating both environmental and business impact. Integrations with external reporting systems simplify compliance and public disclosures. Google Cloud's APIs export sustainability metrics to corporate sustainability platforms, governance dashboards, or third-party analytics tools. This ensures consistent reporting across hybrid and multi-cloud environments. For instance, multinational corporations can consolidate GCP emissions data with data from other providers to produce complete environmental, social, and governance or ESG reports. Automation eliminates manual collection, improving both accuracy and efficiency. These integrations close the loop between cloud operations and corporate sustainability programs, ensuring that progress in the cloud feeds directly into organizational accountability. Policy automation enforces greener defaults across projects and teams. Tools such as Organization Policy Service and Config Validator allow administrators to define sustainability-aware configurations that apply globally. Policies might restrict deployment to regions with high renewable energy content, enforce lifecycle rules for storage, or require idle resource deletion. For example, a policy could prevent creation of always-on instances unless justified. Automation ensures consistency and prevents regression, embedding sustainability into the deployment pipeline itself. This proactive governance replaces ad hoc behavior with repeatable best practice, turning sustainability into a continuous, automated safeguard rather than a manual review process. Case studies illustrate how these capabilities achieve measurable results. Enterprises across sectors, from media streaming to financial services, have used Google Cloud sustainability features to reduce emissions and costs simultaneously. One company lowered carbon impact by relocating compute-intensive workloads to cleaner regions, achieving a double-digit % reduction in emissions. Another implemented lifecycle storage policies that cut both storage expenses and energy use by nearly half. These real-world examples demonstrate that sustainability gains are tangible, quantifiable, and economically beneficial. They show that technology-driven optimization produces outcomes that benefit both the organization and the environment. Balancing sustainability with reliability and cost ensures that efficiency does not compromise performance or affordability. The key is integration, designing systems where environmental metrics complement existing operational goals. For example, combining auto-scaling for energy efficiency with redundancy for reliability ensures that greener operations never reduce resilience. Similarly, lifecycle policies should preserve compliance and data availability while optimizing storage footprint. Sustainability thrives when it enhances rather than competes with reliability and fiscal prudence. thoughtful trade-offs produce solutions that are environmentally responsible, technically sound, and economically sustainable all at once. Progress in sustainability is achieved through iteration: measure, act, and measure again. Each optimization, policy, and workload adjustment contributes to a broader goal of continuous improvement. Google Cloud's tools make this process accessible, transforming sustainability from a complex challenge into a manageable discipline. By embedding carbon awareness into dashboards, policies, and automation, organizations gain both insight and control. The path forward is clear: measure impact, implement smarter configurations, and track results transparently. Sustainability in the cloud is not a static milestone, but an evolving practice, one where every iteration brings technology and responsibility closer together. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.